Hello, children. Well, I'll be absent for for today and next Tuesday. So you will start studying lines, angles, and shapes with a teacher that is gonna be there with you. And this is chapter 3. Okay. So first thing first, start reading chapter 3. Okay, with your teacher. If you want, read it out loud. Okay. Here is have some recap, something you should know about elementary school, but we will study it here also again. Here are some terms and definitions that you should know. What is a point? What is a line? Two parallel lines. Parallel lines are a pair of lines, okay, that are determined, or you can know that two lines are parallel first. If you think they're parallel, for example, I think that AB and CD, those lines are parallel. But how can I be certain? Because they have this little arrow over here. Okay, so when you have two lines that seem parallel and they have this arrow, then those lines are parallel. Okay. Then here you have an angle. It's not a definition, but this is what an angle is for the book. It says when two lines meet at one point, this point, the vertex, they form an angle. The meeting point B is called a vertex of the angle, and the two lines are called arms of the angle. So this is arm AB, this is arm BC, and how do you determine the angle? How do you write it? You say, okay, ABC is the angle, where B is the vertex and is where the angle is located. Okay. Here it says angles are named using three letters. The letters at the end of one arm, A, the letter at the vertex, B, and the letter at the end of the other arm, C. The letter in the middle of an angle name always indicates the vertex. So ABC, where B is the vertex and where the angle is located. One thing I wanna explain here, because sometimes you think, okay, this is an angle, like this piece of cake or this slice of pizza is an angle, but actually this is not the definition of angle, and that's one of the important things that we're going to be studying now. Okay, first we're going to start the definition with points. Okay, point is a location space. It has neither shape nor size. Okay, so you can think of a point as a location space. For example, if you have a page in your desk, blank page, you can determine a point by writing a dot with your pen, but actually that is not a point because it has shape, and it has sides. So the definition by point geometrically is a location space. Okay, that's the definition of a point. So let's say, for example, that I have this point here, it's called A, and I have this point here, it's called B. These 2 points can be connected with a line. For example, this is a line that connects both points. So now what is important is the definition of line. So as definition of a straight line, a line is connected set of points that extend infinitely in 2 directions. So this straight line, extends to the left and to the right infinitely. Okay. Okay. For example, this is the straight line that connects both A and B and goes infinitely to the left and to the right. Okay, and there are infinite points in this straight line. Okay, so that's important what a straight line is. Now we have a definition of a plane. What is a plane? A plane is a two-dimensional surface made up of points that extends infinitely in all directions. There exists exactly in one place through any 3 non-collinear points. Okay, for example, if you have a plane like this, this is a plane that extends infinitely in all directions, even though you have a border here that is all around this plane. Actually, this extends infinitely in all directions. And what it means, any 3 collinear points? 3 non-collinear points means that they're not in a line. Like there is not a line that can connect all three dots. Okay, because if a straight line connects A and B, it doesn't connect C. If a straight line connects A and C, like this straight line, it doesn't connect B. Okay, so a plane is a two-dimensional surface made up of points that extends infinitely in all directions. So this is a plane. So this will help us determine what an angle is. Okay, so now imagine you have a plane. Okay, this is the plane. Like remember, it doesn't have border. It extends infinitely. And you have two dots, A and B, that are connected with a straight line. For example, let's say a straight line. This is a straight line that connects A and B. Okay, straight line connects A and B. Once you draw a straight line, you determine two semiplanes. Okay, this is the semiplane, let's say to the left, and this, or the one above, and this is the semiplane below. Okay, a straight line divides a plane in two semiplanes, in this case the one above and the one below. But I can also have another straight line. For example, let's say if I have an point C over here, and I made a straight line from A to C, like this. So AC is a straight line that determines two semiplanes. The semiplanes to the left and the semiplanes to the right. Okay? So you have three dots are non-collinear. AB, they made a straight line. We can call it minus A. AC determines a straight line. We can call it B. Generally, the dots are written in capital letter, and the lines and are the straight lines are written in small letters. Okay, so straight line A determines semiplanes above and below. Straight line B determines the semiplane to the left and to the right. What an angle is? An angle is the intersection in this case of the two semiplanes. Semiplane A, this is the semiplane from the straight line A that is above, and this, let's see, and this is the semiplane of straight line B to the right. Okay, so what is an angle? An angle are all the dots that are here. All that is an angle. So when you think of an angle, even though you write this, like this symbol to represent that this is the angle you're considering, an angle is defined by the intersection of two semiplanes. Okay, in this case, one semiplane is determined by the straight line A. So A will be one arm of the angle. The other semiplane is determined by the straight line B. So you have the semiplane from B to the right, and all those intersection of those two semiplanes determines the angle. So you write this to express the angle, but actually the idea of an angle is the intersection of two semiplanes. Okay, and here you have infinite points. So that is an angle, not the symbol. The symbol says which intersection of semiplanes you're considering, but the angle is the intersection of two semiplanes. Okay, in this case, one determined with the arm A, this one A. In this case, you will say the angle is C, because you go the upper arm, the arm to the left, the vertex A, and the other arm with the dot B. So this will be the angle we are considering here. Okay, so that is the most accurate definition of an angle, the intersection of two semiplanes. We continue with the book. An angle Here also you have some definitions, angle and other definitions. What are perpendicular? Okay, when two lines meet at right angles. Okay, read this out loud with the teacher and discuss it. Acute right angle, obtuse angle. Okay, straight line. What is a revolution? You should by now you should know how to use a protractor. Okay, so you have to get one for the next Tuesday. Okay, and I will give you, yes, you have to for next Tuesday, not for this class. So there's some exercise here there are some exercise here of how to use a protractor. Okay, how to measure angles. You should know all these two methods. Then you have to measure these angles. Okay, how to draw angles. Okay, use the protractor. Also, you should know all these. Use a ruler protractor to accurately draw the following angles. You can do all this. I think there's no need for me to explain. Okay, and here this is important. This is a relationship between angles. Okay, and some definitions. A complementary angle. Angles in a right angle add up to 90 degrees. Okay, so what are complementary angles? Are angles when you sum them together, you add up to 90 degrees. Okay, so when you add two consecutive angles and they add up to 90 degrees, you can say that those angles are complementary. Okay, in this case, you have A and B. Because this symbol means a right angle, you can say A and B are complementary. So A plus B add up to 90 degrees. Also in this case, you have X and Y. These symbols represent a right angle, 90 degrees. So you say X plus Y equals 90 degrees because there are complementary angles. X and Y are complementary angles. Okay. Supplementary angles, also angles on a straight line, add up to 180 degrees. When the sum of two angles is 180 degrees, those two angles are supplementary angles. Okay, so in this case you have A and B, they add up to 180 degrees. Okay, so A and B are supplementary. What you will say is that, okay, since A and B are in a straight line, okay, A and B add up to 180 degrees. In this case, it's the same because this area, this sector here of a circle, this sector is 180 minus this angle x. Okay, if all these add up to 180 and if you all this you subtract x, you have 180 minus x. So this is this angle. Okay, angles that are round points. You know that angles at a point make up a complete revolution. A revolution is 360 degrees. So in this case, A, B, and C are angles that are round points. So A plus B plus C equals 360. And in this case, all these are angles that are round points. A, B, C, D, and E add up to 360 degrees. Okay, A, B, C, 360. A, B, C, D, and E, 360. If I want to have more angles, then you have to add those angles, and it will still add up to 360 degrees. Okay? Vertically opposite angles. When two lines intersect, two pairs of vertically opposite angles are formed. For example, we have this straight line over here, this line, and these lines. Both lines intersect. So you have the angles with the dots that are equal, and the angles that to the left and to the right that are equal. Here it says vertically opposite angles are equal in size. Okay, x is equal to x, y is equal to y because I have two lines that intersects at one point. Okay, when the two lines intersect, it forms two pairs of vertically opposite angles. Okay, so definition you should know. And here are the exercises. In the exercise, you will be asked to find the value of a certain angle based on the other angles information that you're given. and the relation between those angles. Okay, so it says using angle relationship to find unknown angles. The relationships between angles can be used to work out the size of unknown angles. Follow these easy steps. First, you have to identify the relationship between the angles and the relationship with the angles with the unknown value that you want to find out. Okay. Then you have to write an equations with those relationships. You have to say why do you think that is a relationship, and then you have to solve the equation to find the unknown value. You can solve the equation as we have seen in previous lessons. Okay. So work examples here. It says find the size of an angle marked x in each of these figures. Give reasons. Here we have the angle x, and here we can see, since here we have this little line box, red box over here with the line, and that is a straight angle, you can say x plus 72 equals 90 degrees. You can say because they are complementary angles, okay? Since 72 plus x equals 90 degrees because they are complementary angles, okay? And here you can solve here you have an equation, you can solve the equation. You can subtract minus 72 degrees on both sides. Okay, here in the book, just it subtracts 72 degrees from the right, and just it says 0. You write 0 to the left, so you don't write it. X means equals 18 degrees. In this exercise B, you have x, you have this symbol that means right angle, and 48. So you know that x plus 90 degrees plus 48 degrees add up to 180 degrees because there are angles on a line. Okay, all these three angles are in a straight line, so they add up to 180. And you can solve the equation, and you can find it says rearrange to make x the subject. So you can rearrange to make x the subject. You can solve the equation by rearranging and finding x. In this case, you say, okay, which is the unknown value? This angle. Is there a relation with another information that given at this angle? Yes. 30 degrees. What is 30 degrees? It's vertically opposite to x. And what is the relation between vertically opposite sides? Angles, sorry. Is that they're equal. So x equals 30 degrees because they are vertically opposite. You have to say why. You have to, as the book says, you have to give reasons for the statements. You have to give reasons why you are doing the thing you're doing. Okay. Exercise 3.3. You have to find, okay, in the following diagram, name a pair of complementary angles. Okay. For example, complementary angles are angles ABF. Let's write this down. Okay. In the following diagram, name a pair of complementary angles. Okay, which are complementary angles? Are the angles that add up to 90 degrees. Okay, so which angles add up to 90 degrees? This angle, that is A, B, F, the arm E, arm E, vertex B, and the other arm F, EBF. And where is the angle located? In B. And this angle FBC, FBC, and those angles add up to here 90 degrees. So these are complementary angles. Okay, a pair of equal angles, for example, B equal angles. For example, if this is 90 degrees, then these two angles have to be equal. So E, B, D has to be equal to C, B, G. Okay. And okay, and continue with the rest. Okay, continue with the exercise. And now you have to start doing exercise number 2. For example, you have to find the unknown value. Okay, for example, you want to find, in this case, let's see, for example, letter C. You want to find, okay, here for example, we have this exercise. So you can make a relation between, okay, let's say, where is it? Here we have the intersection of these two lines. Is there a relation between 115 with this value y? Yes, you can say 115 equals y because you have to give us a reason of your statement, because they are opposite vertically opposite angles. Okay, angles. This is the relation between the angle, the information, and the unknown value, and this is why you are saying that. Okay, why you have to define. Sorry, like defend or say why. You can say that this is a relation between 115 and y. Okay, and now I have to find x. Okay, is there a relation between another angle and x? Yes, I can say that 115 degrees plus x equals 180. You have to write because. Why? Why can I say that this is a true relation? Okay, why I can say that? Because they are supplementary. And why they are supplementary? Because they're angles on a straight line. Straight line. Okay, they're angles on a straight line. So I can make this relation. Okay, so now I have to make x rearrange to make x the subject, right? So x equals 180 degrees minus 150 degrees. X equals, I think, 65, right? 65 degrees. Then you have to write the relation. Why you say that? They are supplementary, but why? Because they're angled on a straight line. Okay. So all these add up to 180 because angled on a straight line. Okay, here we have all the rest of the exercise. Do them, try to solve them with your teacher. Okay, here also find x, the value of x. And then we'll discuss next lesson angles on parallel lines. I will send you now some other exercises. Here are some other exercises. You can do exercise number 1, 2, 3, 4, 7, 8, 9. You can do 10, 11, 12. You can also do. Okay. You can also do this exercise over here, these ones. And any questions that you have, any doubt, you can send me you can write it in the Google Classroom. Okay. Well, good luck with all these exercises. Remember to read all the first part of the chapter, so you know all the definitions well. Bye bye.